You can hear me?
Yeah, I can hear you loud and clear.
Oh, great. So now you can record. Okay, right. Oh, I thought Dr. Eric was here earlier. So let me just look for him and see.
He just stepped out, said he was coming back. I wanted to go. He's coming back. He joined the group back. Some few minutes.
Oh yeah, I can see him here actually. So Brain, bye bye. Take care.
Okay.
See me out there. Expect your see. We expect to see me.
Hey folks, can people hear me? Sorry for the delay.
Yeah, we can hear you, Eric. Yeah, I can hear you.
Excellent, good deal. Sorry about that, everyone. Had to update Zoom, but I think we're good now. So now let me, you know what? I need to be upgraded to be a host, not a participant. Are there DSN folks on this? Because okay, I can't share my screen as a participant.
Okay, I'm working on it.
Great, thank you. All right, well, while we're waiting, has anyone gotten any particularly interesting talks so far? Yes, which ones have you, what's been your favorite talk so far?
Okay, hi Eric. Please try sharing again.
Great.
Yeah, please try sharing again.
Yes, it looks like I can.
Okay, great.
Let me switch.
Oh, great.
All right, let's try playing. Can everyone see that?
Yes, very clear.
Does it have a bunch of, can you also see the comments, or is that just for me?
No, we can't see the comment. We can only see the mechanism design.
Okay.
Yeah.
Excellent.
Great.
Good deal. All right. So thanks, everyone. Really glad you could make it. Sorry for the technical difficulties to start. Just 10 minutes late. That's not so bad, I guess. So my name is Eric Sodomka. I'm a research scientist at Facebook. And if you're here, you had either some curiosity or some familiarity and wanted to learn more about mechanism design, or maybe you haven't even heard of it before and I just you randomly picked and I got lucky. But whatever the case is, very happy that you're here. So I won't assume that you know anything about mechanism design. This is sort of a course for beginners. It's an introductory course. If you were here, was there anyone at Data Science Nigeria last year who is also here this year? If so, this will be a lot of the same material. I am sort of assuming that most people here were not here last year. But if it turns out a lot of people were here from last year, next time around, I will change up the content to cover other topics besides what I'm covering here. But there will be a little bit of new stuff at the end, even if you were here last year. I'll say this is primarily based on some lecture notes by Tim Roughgarden, who's a professor, used to be at Stanford, now is at Columbia University in the United States. Really one of the best instructors I know, really clearly teaches concepts on mechanism design. So, and he has courses online for free. So if you're interested in what you're hearing, I'll have some links at the end where you can see some of Tim's courses. All right, so to start, we have a very, let's see if I can go to the next slide. Very simple problem, 2 + 2 equals. So what I'm hoping everyone can do here to start, just fill something in the blank put it in the chat. Anything except for 4. There you go. Good job, Michael. So all I want is, I want to see that people are able to use the chat. You're used to using the chat, and you don't have to feel like you have to say a right answer to anything that we're talking about to be using the chat and participating here. I'm hoping this will be very interactive, but it can't, I think you can learn a lot more if you're willing to put your guesses out there, even if you don't know the answers exactly. So I encourage you all to use the chat to do this. So great. So it looks like you guys are doing a good job. So a lot of string concatenations, maybe some binary representation. Very good. Okay, cool. So that was just a little test. So first, I want to start, before even diving into the mechanism design aspects, I want to call out an announcement that was just made in the last month and a half, that Facebook is opening an office in Lagos, Nigeria. So very excited about this. So will be around in the second half of 2021 is when it's opening. And it will have engineers there as well. So if you are interested, I would love at some point if you end up being one of my coworkers. So I think this also, the fact that we're opening it here, speaks to, for one, Data Science Nigeria and all the amazing stuff that this organization has done to build up talent in Nigeria. It's just amazing what's been done, and all of you involved are part of that. So kudos to you for being involved in this session. Super inspiring what Data Science Nigeria has done, and I'm really inspired by, I know that everybody who got into this session has done a lot of courses, competitions, and that's no small feat for you to even be here. So congratulations on that. I'm very, very impressed. So if you are interested, so I added a link there in the lower right corner, bit.ly/Eric-referral. If you would like, we have sort of a referral program within Facebook where we can sort of submit referrals for people that are interested in working at Facebook. If you'd like to, if you're interested, feel free to fill in that form. It's submit your resume, answer a few questions. I can't make any sort of guarantees that just by submitting that what's in that form that you will get a job at Facebook, of course. And even even more than that, I'm limited in the number of referrals that I can make. But I'll definitely read through every request that's submitted, and I'll try to give resume feedback as well for those that are interested. Yeah, so either way, hopefully something, I would consider it a huge success if someone ends up joining Facebook as a result. Yes, someone said, can you share the link? That probably would be easier than, so let me just say, oops, bit.ly/Eric-referral. All right, hopefully that works. Good. And I'll have links at the very end as well. And if needed, I can share them after the fact as well. All right, so now let's dive into it a little bit more. So one last little preface. Oh, I should say, yeah, good question. So I am in the United Kingdom office, actually. I used to be at the US office. So yeah, to give a little bit more of an intro, I guess. So I've been at Facebook for just over 7 years now. So quite a long time. And the first 6 or so of those years was spent in the United States, the Menlo Park, California office, or the main headquarters. And since then, I've moved to the United Kingdom. My wife is a professor here, so moved here to join her. And yeah, so now I'm in the UK office. Both offices are great, as well as many others around the world. So wherever you're interested in joining, that would be exciting. Okay, so this last little link here is for a Facebook group mechanism design. This was originally for Data Science Africa, hence the name Mechanism Design at Data Science Africa. But it's sort of the same. Contains Data Science Nigeria folks as well from last year. This is where I'll post any links to courses, research grants related to mechanism design, things that if you're interested in what you see in this tutorial, this would be a good group to join. And on top of that, at the very end of this tutorial, we'll give out some prizes. So we've got some books here. Let's see, we got some mechanism design books here as well. So we'll give out some of these. If I was there in person, I would just physically give them to you. But we'll do the best that we can and either mail them, or if we'll find some way to make it happen remotely. So you'll just have to join this group. It's basically a drawing that we will have at the end to participate in some game. So if you're already part of this group and you want to be eligible, just remove yourself from the group and instantly join again in that way, because I will look at those that have recently joined the group to decide. Okay, without further ado, we'll show that link in a moment as well. I guess I can put it in here. bit.ly. All right, so that is for this Facebook group. All right, so now we get to a motivating problem here. Great, I see some people just joined already. Okay, so here's the problem. So we're gonna have to imagine that COVID is not a thing and we're all actually in the same room. And I come in, over my shoulder is a huge bag. Let's say, how many of you are there? Are there 40 some people in the 85 people in the room here? So we just have this big bag full of books on AI, data science, various books that I think you might be interested in. And I'll just say, these books that I happen to be showing here on the screen, I'm not endorsing these books or anything like that. This was just from a snapshot from a Google search. So in any case, I have a bunch of books and I want to figure out, I want to give these books out. Okay, so there are all of you in the room, 85 of you in the room. I have 85 books. I need to decide which books are going to go to which people. So the question is, how should I do that? And so that's the first thing that we're going to talk about. This is really the question. Imagine, really, I have this bag full of books. I want to give them out. What is the algorithm I should use to give out these books? So let me go to the next slide. So we're going to talk about different ideas here, but just to get the creative juices flowing, I'll throw out some initial idea. So this is an initial proposal that we'll call random assignment. So the way that it works is like this. There's just two steps. First, we're going to randomly order the attendees. So all of you is going to get a random number between 1 and 85 or whatever the number of students is here, or participants. So everyone has a unique number. We're going to go through starting with 1 all the way down. So in that order, we're going to give each attendee a randomly chosen book amongst those remaining, right? So basically, I'm just sort of wandering around the room, reaching into the bag, pulling something out, saying, oh, here you go, Brian. Oh, you don't care about machine learning, or you have this book already? That's too bad. Go to the next person. Here you go. Oh, you don't care about natural language processing? That's too bad. Here you go, and so on until everybody has a book. Okay, that's my initial proposal. So here's the point of discussion. And since if we were physically there, we would discuss with a neighbor. What we're going to do instead is first just think about this and really write something down, the answers to these questions, and write them down in the chat. So first, do you have any complaints about this random assignment procedure? And second, can you come up with anything better? Okay, so we're really going to take a few minutes just for you to think about this. I really want you to go through this exercise. So I've again written down what this random assignment is. Couldn't be easier. Choose a random person, choose a random book, give it to you until I run out of books. Okay, so that's the question. So go ahead, think about this, and really just I think just post things in the chat. Let's hear your thoughts. No wrong answers here. You don't need particularly well-formed ideas, just any ideas you have. Let's hear them. Let's maybe start with this first question. Do you have any complaints? Okay. Doesn't factor in choice and preference. Okay, Ibrahim is having a network problem. Ibrahim, I think everything is on this slide. I'll say it again very briefly. We're imagining I have a bunch of books. There are a bunch of you. We're all in the same room, let's pretend. And I need to decide how to give these different books out to each of you. And the way I'm proposing to do it as an initial idea is just randomly give them out, randomly give the books out. And the question is, do you have any complaints about me giving these things out randomly, for starters? Okay, so let's hear what people have said. Let me go back. Okay, so it doesn't factor in choice and preference. Very true, right? So I just, it doesn't matter if you wanted some particular book. I didn't even give you the option to say what you wanted. Give the available books numbers, then ask people to choose from the numbers. Good, that seems reasonable. So we have all these different books. This is a 1, this is a 2. People are going to choose numbers. So there's a question of, what do we do? Let's say that everybody chooses book number 1, right? We still have to, I think that's an interesting idea, give the books numbers, ask people to choose between them, but more detail is needed for a solution there, because it's, we don't know what to do if different people chose the same number and I have only one of those books. Ernest says the random method will not be efficient in the sense that it does not take into consideration the desire of the recipient. Good, very true. We're ignoring preferences here. You might be giving a book to someone who needs another book. Yep, very true. So we might not be giving a book to someone might want a different book than what we've given to them. We have a proposal. Let's do first come, first serve. Good idea. We'll get to that. Okay, good. A lot of good answers here. Okay, let's spend a couple minutes actually going through a few more of these. So although everyone has a fair chance of being chosen due to random selection, the con is the book might be given to someone who doesn't want or need it. Yep. The desire of attendees needs to be considered. Yes. Okay, good. I think all of these are good answers. Oh, someone's been in this. Someone knows a little bit of mechanism design here. Random might not be the best because it won't be Pareto optimal. How do you know what Pareto optimal is? So good, we'll get to that. Well, we can always group people according to the books available, and we can choose randomly from each group. Okay, so we have some concrete proposal there. Whoop, sorry. Okay, so here's some complaints that I think we're hearing. And thanks, kudos to you guys for all the participation here. I think someone is unmuted. If you don't mind muting yourself, unless you're trying to ask a question. Okay, good. All right, so here's some complaints that typically come up here. So 1, it doesn't consider what I want, this procedure. Many of you said that, right? We're just giving books away randomly. Second, nobody mentioned this, although the Pareto optimality comments was getting at that, although no expectation that people, you know what that means at this point. But consider this. If I did randomly give these books out, it seems very likely that you might get this book and think, oh, I already have this book. That's nice, but what do I need this for? And then you look at your neighbor and you see the book that you actually want. And meanwhile, your neighbor is saying the same thing. Oh, I have this book already. Whoa, spoilers. Sorry. There we go. Okay, so if that were the case, right, it seems very reasonable that you might just want to trade books with your neighbor, and both of you are better off. If each of you happen to get a book that you already have, both of you might be happy to just switch books so that you have something new. And so that seems like, given that this whole procedure was about giving these books out, if you then have to go rearrange these books, that you have this allocation after the fact, that kind of suggests the way that I'm assigning these books needs some improvement. But a benefit of this is it was pretty quick and easy to, especially for me, if I just have to go around pulling things out, I don't need to be considering people's preferences, just digging in and grabbing something. It really couldn't be much quicker and easier than that. So, there are pros and cons of these of this procedure. Okay, so then the next question is, did you come up with anything better? And so let's now talk about that. So in the chat, if you've already said it, maybe say it again, because we have a lot of messages here. So specifically now, I'm not interested in what the problems are. Okay, so we've identified the complaints, but now the alternatives. Can you come up with some alternative procedure? So someone said first come, first serve. And if someone wants to elaborate on what that means, go ahead. So a better approach is to group attendees according to their preference, then randomly assign a book to its appropriate group. Okay, so we somehow need these attendees to specify their preferences if we're going to group them. And then we need to come up with some way to group them if we did something like that. So we would need to define that. But then the randomly assigning a book, to its appropriate group. Okay, so it's trying to do something with preferences there. It sounds like that proposal was. Genevieve says, group people by their book preference and give assignments based on these groups. So a lot of grouping. Okay, so the question, to repeat the question, it's at the very top of the slide. Can you come up with a better procedure than this random assignment? A better procedure than randomly allocating these books. Next, we have give each book a number and let pick and ask questions why the person needs it. Okay, so we're giving the books a number. So there's some process, it sounds like we're evaluating maybe who needs what books. So it seems like it could be reasonable. Next we have, I propose grouping them based on the category of books you have and give them out. Okay, so this is a good point. There might be different types of books. There might be the AI books, the machine learning books, computer vision books. But then there's still the question, even if we've done this grouping, how do you actually decide how to give them out, right? So we need to be very crisp, right? This random assignment, I've really fully specified what the algorithm is. So that's the question is, can we come up with something very precise like that? Classify the books into different levels of expertise, then randomly give out books to participants in each level. Okay, that's good too. So different books might be beginner level books, we might have graduate level books. And so the thought is we do some classification of the books, and then it looks like we do some classification of the participants as well. And then we're randomly giving out books. So at the very least, those that are experts are getting books that are for experts. So that's a good idea. I suppose a challenge might be that different people are experts in different things. I may be an expert in mechanism design, but I am a beginner when it comes to computer vision. And so, it becomes, which of these different, does that make something that could be useful? Okay, here's another suggestion. Share the books and allow trade by bartering. So that's an interesting idea. So we don't necessarily have to have each person have a single book. So that's number one, is we could give these group books out to groups. And then also there might be some like distributed process where people can sort of decide what books they want through this bartering procedure. Good. Let's see, read a couple more here. So you got 10 books to give out. Give a short test and pick the first 10 or best 10 and ask them to submit a list of the 10 books in the order they prefer. Then give out the book in that manner. If the first book of a person's list isn't available, give them the next. Okay, that's interesting. So this is flawed. It's basically some sort of merit-based allocation. So we'll give people a test. Whoever did best on the test is sort of getting first choice of book. And if their first choice isn't available, they can add the next choice. Good. So these are all reasonable ideas. Great. So let's take this. Here's an alternative mechanism for you. And this is actually pretty similar to, someone mentioned first come, first serve. I think this is, you could kind of think of this as first come, first serve in some ways, except the first come we are randomly deciding. So I'm calling it choose your favorite. So we'll just like before, we're randomly going to order the attendees. So everybody gets a number, unique number, 1 through 200 or 1 through 85, however many attendees there are. Then we're just going to, so this is your ticket. So I'm going to call up the first person, number 1. And instead of pulling a book from the bag, I'll lay all the books out on a giant table and let the attendee choose the first book or choose whatever book they want. Okay, so they get their first choice. The second, whoever has ticket number 2, they get their choice amongst everything that's remaining, and so on. The third person gets their choice of everything that's remaining, and so on. Does that make sense? Sorry, guys. My mouse cursor isn't visible for some reason, so it's hard for me to scroll in the chat. Okay. So yeah, so that's the proposed alternative. Does this make sense? Choose your favorite. So again, a pretty simple mechanism. Give everyone a random number in this order, randomly assign attendees their favorite book amongst those that are remaining. Yep, good, makes sense. Okay, so that's one alternative mechanism. We can talk about the pros and cons of that. But one thing that you might find annoying if we did that is, it sounds like the way that I described it, everyone kind of had to wait in line for it to be their turn. And then they sort of have to, so someone's waiting a very long time in order to choose a book. So one question is, could we do this a little bit faster so that I do the allocation on my own time? Right, so it does take a lot of time. Oh, so someone asked, how do you give out the tickets to avoid bias? So that's an interesting question. I'm saying we randomly give out the tickets. So, right, I'll shuffle them up, turn them face down, and I'll just randomly give them out. It's not based on anything about anything about you. It's in that sense, it is not biased because it's oblivious to everything, anything. It's just a random shuffle. Okay, so back to this question. So could I allocate the books on my own time? So here's an alternative to what I just described, which we could call choose your favorite by proxy. And the way that this works, it's very similar, except we're just going to get rid of this waiting in line aspect. Okay, so what we could do is have, as a first step, everyone is going to, instead of waiting in line, you're going to submit your preferences. So you're going to write down on a piece of paper a list of your most favorite book to your least favorite book. So you'll write them all down, you'll submit that to me, and then I'll take all these in. I will shuffle your papers, your list of preferences around. So effectively everybody's sort of given a random number. And I'll pull the first one off the list. So this is the first person who's listed their preferences. And I'll just look at the first book. I'll look at their favorite book, and if that's available, I will assign that book to that person. If it's not available, I'll just go down to the second item in their list, the third item in their list, and so on. So I'll give them their favorite book amongst those that are still remaining, according to the preferences that this person has reported. So, note, I said according to their reported preferences. The point there is, I don't actually know what your favorite book is. I sort of have to, I guess I'm taking what you are saying is your preferences at face value. So you are submitting your reported preferences. You know what your actual preferences are. You submit some report of what those preferences are, and I'm going to act like those preferences are what you actually want. Okay, so that's this third procedure, a mechanism. So this procedure for allocating these resources. And this procedure actually has a name, right? We were calling it choose your favorite by proxy, but it has a name in the mechanism design literature. It's called the Serial Dictatorship. So why is it called this? Well, serial meaning one at a time. In sequence, we will consider one person after another, and on their turn, they're the dictator, meaning they get to say exactly what happens on that turn. So they get to say exactly what book they get amongst those that are remaining. So serial dictatorship, that is the first sort of keyword to remember, and this is how it works. Okay, so at this point we have a few different mechanisms. And the question is, how do we know whether one is better than another? Which should we use? So in what ways is serial dictatorship, this second mechanism, how is it better than this other mechanism, random assignment? And what does it even mean for a mechanism to be good? How do we compare, we know what it means for a number to be greater than another number. What does it mean for a mechanism to be greater than another mechanism? This is an important question, and there is not a single right answer to this. But I think what this is getting at is we should be precise about particular definitions, and then we can say whether or not these different mechanisms satisfy some criteria or satisfy criteria better than another one. So someone mentioned running time. Yeah, so maybe one of these mechanisms is faster to execute than another. So I'm just going to read through the chat some ideas that you've said. Feel free to shout out ideas of what does it mean for a mechanism to be good. Best assignment. Yeah, so if one of these mechanisms is assigning books better than another, we might say that that mechanism is better. But then that begs the question, what does it mean for one assignment to be better than another? And so we could ask the same question about that. Similarly to accuracy. So what is it exactly does it mean for a mechanism to be accurate? Level of satisfaction. So that seems like something we could capture. Maybe we, so how would we capture level of satisfaction, Genevieve? Like one idea, we could survey people after the fact. We could base it on, like if we knew what people's actual preferences were, we could see how close people got to their first choice, second choice, and so on. We would need some way to summarize that into a single number. Yeah, there are trade-offs to be had here. So we want some way of knowing how well the mechanism is sort of giving people what they want. So we need to know preferences for that. Someone asked to see the previous slide, so I'll go back one moment. So this is Serial Dictatorship. So again, everyone's submitting their preferences over books. We're randomly ordering attendees, 1 through 200 or 1 through 85, however many people are here. In that order, when it's your turn, you get to choose whatever book you want amongst those that are still available. Okay. So just to list off a few more things that people are saying for what does it mean for a mechanism to be good: computational resources, level of productivity. Yes, you can have the slides after the class. Okay, so Martha, for level of productivity, then there's the question of what exactly do we mean by level of productivity? Like, that could be a good answer, but we need to know precisely how are we measuring productivity. So that's sort of the follow-up question for you. The rate at which books are given off, the level of individual satisfaction. Yep, so these are all reasonable ideas. The average level of satisfaction. Okay, so I'll focus now on a couple different ideas that haven't been, I think some of these haven't been mentioned. Although someone mentioned at the very beginning this notion of Pareto Optimality. So this is one notion of goodness that we will talk about to start. And this is getting at, some were asking about, talking about the level of satisfaction of the assignment. Okay, so in some ways this is capturing that. So an outcome is Pareto optimal. So this is another keyword to remember. So an outcome is Pareto optimal if you can't make someone better off without making someone else worse off. Or another way to say this, an outcome is Pareto optimal if there's no alternative outcome for which everyone is at least as happy and someone else is happier. So a way that you could think about this is, after we've given out these books, however we did it, if we can come up with some other allocation of books where no one is worse off, but people are better off, then this is Pareto optimal. So if after we gave out these books, we could find this instance where there are these two people, for example, where each of them has a book that the other one prefers, well, now there is an outcome which is exactly the same as before, except switch the books of these two people. Now everyone else is just as well off as they were before because they're getting the same books, except for these two folks are both better off than they were before. So that original outcome in that case is not Pareto optimal, because there is this different outcome where these two have different books, where people are worse off without making, or sorry, some are better off and no one is worse off. Does that make sense? Well, we'll test you on this in a moment. For starters, do we need any further clarification of this? Maybe we can just go to the examples. Okay, good, thanks. So we'll explain it one more time. It is a tricky concept if you haven't heard of it before. So the basic idea is, okay, so an outcome is just the allocation of books. So we've given out all these different books to everybody. This outcome is Pareto optimal if it is the case that in some ways is sort of locally the best we can do. So if it is not the case that we can make some people better off without hurting anyone else, then it's Pareto optimal. So imagine, so this is the simplest, I think, example is like, if you can see that after you've given out the books, if there are two people that are willing to trade books that would prefer that, it is definitely not Pareto optimal. Because those two trading books, they're making themselves better off and no one else is being made worse off. So why don't we go through some examples, and I think that might help to make it more concrete. And then if there are still questions, we can go over that. Okay, so here's an outcome. So what we have here are 3 people. Okay, so not 85. So we have 3 people. We'll call them A, B, and C. And we have 3 books, books number 1, 2, and 3. And what we have listed here are the preferences of A, B, and C. So person A likes book number 1 the most, then they like book number 2, then they like book number 3 the least. Person B, meanwhile, likes book number 2 the most, then they like book number 1, and then they like book number 3 the least. Person C likes book number 3 the most, then book number 2, then book number 1. Excuse me. And the lines connecting people to books, those are showing the allocation. So person A is getting book 1, person B is getting book 2, and person C is getting book 3. Okay, and so the question is this allocation Pareto optimal? And feel free to comment in the chat if you think it is Pareto optimal. So we've got some answers coming in, a lot of yeses. We've got a no, good. Okay, so we've got mostly yeses, we've got a no as well. All right, so everyone is equally satisfied. Everyone gets what they want the most. Okay, good. If you just have a guess with an explanation, go ahead and put it in, because I think this is exactly the point where we get to clarify if there, is some miscommunication here. This is exactly the time where we can correct it. So let me go through some of these answers. And the person who said no, if you would like to explain why you said no, the reasoning, that would also be helpful. So let's go through some of these answers. So first, yes, it is Pareto optimal because A, B, and C get their favorite books. So in fact, this outcome is Pareto optimal. That is correct. So the person who said no, I still encourage you to explain your rationale, because that might help correct, help you see why it is, in fact, it is Pareto optimal. Yes, so because these 3 are getting their favorite books, it's not possible that we can come up with some different outcome where someone is being made better off. So, right? So there's no way that we could make someone happier. So look at this second definition, right? There's no alternative outcome for which everyone is at least as happy and someone is happier. Okay, so we know that there is no alternative outcome where someone could be happier, because all 3 of these guys are getting the thing that they want, the book they want more than anything else. So we can't possibly come up with some outcome that makes someone happier. So this is Pareto optimal. Just to go through a few more of the responses, because it looked like it was helpful for clarifying some things. So a lot of people just said yes. Okay, so here we had another response that was, yes, it's Pareto optimal because everyone is equally satisfied. So to clarify, it is Pareto optimal, but that is not the reason why. And in fact, I can come up with examples where everybody is just as equally satisfied, but it's not Pareto optimal. For example, suppose that all 3 of these people got, well, they can't all get their least preferred book, but let's say that C gets book number 1. So C gets their least preferred book. B gets their least preferred book. So B gets book number 3. And A gets their second least preferred book. So they get book number 2. Okay, well, I guess that isn't an example of everyone being equally satisfied anymore. So let's, okay, so I would have to change the preferences, but let's say that A A's least favorite book was book number 2, and I gave all 3 of them their least favorite book. Okay, so everyone is equally satisfied in that case, and they're equally dissatisfied. But it's not Pareto optimal, because we could still come up with some outcome where everyone is at least as happy and someone is happier. Specifically, we could give all of them their most preferred book. Okay, so that was so just going through the chat, again, that was in response to the comment, yes, because everyone is equally satisfied. I'm saying, well, it is Pareto optimal, but it's not Pareto optimal because everyone's equally satisfied. Hopefully that made sense. All right, if I can get to the chat again. Each person gets a book option that is better than the others in that category. Let's read some more of these. No one has to exchange their books to be satisfied. Yep, this is true. Everyone gets their best preference. Everyone got their top books. Okay, good. Yes, okay, so someone says, although I do feel on a larger scale with a larger number of people, someone would definitely have a favorite book, the same favorite book as someone else. So how would that be solved? So that's a good point. So this was an outcome where it was easy to say it was Pareto optimal because everybody got their favorite book. Let's go to another example. Oh, but before we do, so we have a comment about the no, that it's not Pareto optimal. They are satisfied that they collected books, but not happy because they don't have their most preferred book. Oh, maybe that's, I think that is probably in response to what I was describing before, this other example, because in this example that's on the screen, everybody is in fact getting their preferred book. Okay, so to clarify, John, that's actually not true. If everyone is equally, John, thank you for, so this is exactly what I was hoping for. So, because we can clarify things. So thank you, John, for saying this. So if everyone is equally dissatisfied, then I guess it's Pareto optimal. That's not actually the case. So if, that's not necessarily the case. So we could change this example where, right, let's say we would have to change person A to prefer book 1 the most, then book 3, then book 2, and give everybody their least preferred book. Everyone's equally dissatisfied, but it is not Pareto optimal in that case. And why is it not Pareto optimal? Because there is an alternative outcome, namely this one where we give everyone their most preferred book, where everyone is at least as happy and someone is happier. So that giving everyone their least favorite book would not be Pareto optimal. So Genevieve asks, Pareto optimal is achieved when they all get their most preferred book, right? That is correct. But there are, if everyone's getting their most preferred book, it's definitely Pareto optimal. But it can also be Pareto optimal even if some are not getting their most preferred book. So let's go to the next example. We have a few examples, so maybe we'll see this. So this one is Pareto optimal. Next up, so what did I change here? I just changed the allocation. Okay, so now person A is getting book 1, person B is getting book 3, and person C is getting book 2. So the question is this Pareto optimal? No, Manuel says no. Okay, so for the person that said they don't get it, so the question is this Pareto optimal? So we have a lot of no's coming in. So I changed the problem slightly. What I changed was the allocation on the screen. Person B is getting book 3 now, person C is getting book 2. So is it Pareto optimal? And so we have people saying no, no, no. because B and C could exchange their books and they would both be better off. Exactly. So look, if B and C exchanged, okay. I see a comment that's worth addressing. So sorry, let me finish my thought. So in this outcome is not Pareto optimal because B and C could swap books. So B gets book 2 and C gets book 3. Really, if we just went back to the same allocation as before, right? In this alternative outcome, person A is just as well off as they were before. They're getting the same book, and both B and C are happier than they were before. Okay, so this outcome is not Pareto optimal because we can come up with this alternative outcome where B is better off, C is better off, and A is just as happy as before. Does that make sense? So this is not Pareto optimal. And for the person that said they're all happy, but A is happier, the comparison to be making is a person's happiness between these different outcomes. So we're not comparing A's happiness to B's happiness. We're comparing A's happiness in this outcome to B's happiness in this other outcome. Okay, it's not because B gets book 3, which is his least preferred, and C is getting book 2, which is his second most preferred. Hence, it's not Pareto optimal. Yes, and specifically, it's not Pareto optimal because they could make this switch. B and C could make this switch where they're better off than they were before. Okay, well, last example. Okay, so we have changed, what did I change here from the last example? I changed the preferences. So now we have person A likes book 1 more than book 2, more than book 3. Person B likes book 1 the most, then 2, then 3. Person C likes book 2 the most, then book 1, then book 3. And the question is this outcome Pareto optimal? Genevieve, excellent question. Please clarify on this. What if, so I'm reading a comment here. What if A gets their most preferred, B and C get their least preferred, and exchange between the remaining two won't still meet their satisfaction? Is that Pareto optimal? That would be Pareto optimal. And we'll go into that in more detail if we need to here. So let's just give people a chance to answer this. Try to answer, so is this outcome Pareto optimal? And why? Why is it Pareto optimal, or why is it not Pareto optimal? So it's good that you're saying yes or no. I think what will help clarify is if you say why it is the case. So someone says yes, there's no other alternative. There's no way anyone can be better off by exchanging books. You can't make it better than this. Okay, so good. This is in fact Pareto optimal. So for those of you that said no, pay special attention here and think about what the reasoning was for why you said no, and see if this makes sense. So why is it Pareto optimal, right? And I think the confusion for those that said no, you're probably looking at B and saying, well, B's getting their least favorite book, right? So that doesn't seem good, that, right? B is getting something that they definitely don't like. And so maybe if you don't go through the steps, you might think surely there must be some, well, there definitely are different outcomes where B could be better off, right? If B got any other book besides book 3, they would be happier. However, in order for B to get a better book, a book they prefer more than what they got, it would mean that either person A or person C is getting a book that they like less, right? A and C are currently getting their favorite books. And so for B to get a different book, it means that A or C must be getting worse off than they were before. So there are no alternative outcomes where there are definitely outcomes where you could make B happier, but in order to do so, you would have to make somebody else worse off. So there's no way to make someone better off without making someone else worse off. You can't make A and C better off because they're already getting their favorites. And you can't make B better off without making A or C worse off. Good. All right. Someone says, now I get it. Excellent. So does that make sense? I think this is the key example that for those of you that said no, hopefully this is the example that corrects the misunderstanding. Okay, great. All right, so that is one notion of goodness, Pareto optimality. So now we can ask, is the outcome from, say, the serial dictatorship, is that Pareto optimal? Like, could we say anything? It would be nice if we had a procedure that always gave outcomes that are Pareto optimal. And so the question is, could we prove anything about this serial dictatorship, about the outcomes that come out of this mechanism? So just give it some thought. I think this is involved. It would be hard to, I would be impressed if this just is obvious to someone, whether or not the serial dictatorship outcome is Pareto optimal, but give it some thought. Maybe just say what your intuition is in the chat. Do you think that the serial dictatorship outcome is Pareto optimal? If you have a reason for thinking this, feel free to say it, but if not, you can just say your intuition. And remember, this is kind of a mouthful. If it might be that you look at this question and your eyes glaze over, right? Because there are two pieces of jargon here that you need to remember. You need to know what serial dictatorship is, and you need to remember what Pareto optimal is. So that's the reminder. These are just simply terms. So the serial dictatorship, again, was for randomly ordering people. We're going to match everyone with their most preferred book. And an outcome is Pareto optimal if there's no alternative outcome where everyone is at least as happy and someone is happier. So we have a lot of no's. Oh, and okay, good. So Favor says, what is serial dictatorship outcome, right? So I specified the mechanism. So the outcome is, I should say, any outcome. So from running the serial dictatorship, you get an outcome, which is an allocation of books to people. And the question is that outcome always going to be Pareto optimal? Okay, so we had some yeses, some nos. So we're going to walk through this. So if you look at Tim Roughgarden's lecture notes, you can see the proof of this in general. I'm going to prove it for this case where there are 3 people and 3 books. So let's just start with an outcome. And this, by the way, it's okay if you don't get all the steps here, but I'll at least give the intuition. And we've shared the slides, so you can go back if needed. Okay, so here's the reasoning. So let's just start with some particular outcome that came from the serial dictatorship. So we'll say that this outcome is such that person A got book 1, person B got book 2, person C got book 3. Okay, and we will label books 1, 2, and 3 so that this is the case. Like if A got book 2 and B got book 1, well, we're just going to call we're going to label the book such that A got book 1, B got book 2, and C got book 3. Okay, so that's the outcome from the serial dictatorship. And so the question to answer to say if this is Pareto optimal, we need to think, well, can we find a better outcome? So one where everyone is just as happy as they were before, and some are even happier than they were before. So if we can show that some outcome like this exists, then we know that this outcome is not Pareto optimal. Because if there's some outcome, by the definition of Pareto optimal, right? We're saying an outcome is Pareto optimal if there's, by the definition in that lower left corner, it's Pareto optimal if there's no alternative where everyone is at least as happy and someone is happier. So if we can find this alternative outcome that, you know, where everyone is at least as happy and someone is happier, then it must not be Pareto optimal. And if we can prove that that outcome, alternative outcome doesn't exist, then it is Pareto optimal. All right, so in this small problem, we can actually just enumerate all of the possible outcomes where we're matching everybody. So in the upper left corner, that's the outcome from the serial dictatorship. Let's see, so how did I do these? So the leftmost column is the outcomes where A is matched to book 1, and then there's 2 possibilities for B and C. Those middle column, that is for when A is matched to book 2, and then there are 2 possibilities for what B and C get. And then the third outcomes are when A is matched to book 3, and then there are 2 different outcomes for B getting book 1 versus getting book 2. Okay, so that's all the possible outcomes. And now let's try to find this better outcome where everyone is just as happy as they were before and some were happier. Oh, and I should have said that the outcome from the serial dictatorship, we're assuming that person A is the person that chose first, B is the person that got to choose second, and C is the person that got to choose third. And in fact, we're just, you know, going to label those people such that this is true. So whoever got to choose first, we're calling them person A. And whatever book they chose, we're calling that book book 1. Okay. So now the question is, can we find this better outcome where everyone is just as happy and some are happier? Okay, and these are all the different outcomes. So first of all, the thing to note is A got to choose in the serial dictatorship. Since they got to go first, they got to choose whatever book they wanted. All the books were available to them, and they chose their favorite. Okay, so we know definitively that A prefers book 1 to any other book. They like book 1 more than book 2, and they like book 1 more than they like book 3. Based on how the serial dictatorship works, right? So A got to go first, and they were matched with their most preferred available book, and all books were available when they got to choose, right? So we know that any of these outcomes that I've just blacked off, A is worse off, right? Because A is getting some book that they like less than book 1 in all of those outcomes. So we know that none of those outcomes could be one where everyone is just as happy and some are happier, because A is not just as happy in those outcomes. A is less happy. Okay, so we're eliminating all of those from being a better outcome. And then next, let's look at this second one. So what we know from the serial dictatorship, so when B got to choose, so B was the second person to choose, book 1 wasn't available to B, because A chose it, but B did get to choose between books 2 and book 3. And we know that B chose book 2 over book 3. So in this alternative outcome, B is worse off, right? Because B got a book that it preferred more than book 3 in this original outcome. So this couldn't be the outcome. This one I'm blacking off here could not be this better outcome where everyone is just as happy and some are happier, because B is definitely not just as happy or happier. B is worse off than they were in the serial dictatorship outcome. Well, what's left? So there's only one outcome where nobody's worse off than they were in the serial dictatorship outcome. And this is exactly is the serial dictatorship outcome. Okay, so this is saying that we were trying to find some counterexample, basically. We were trying to find this alternative outcome where someone was happier and everyone else was just as happy. And we showed that there is no such outcome. So in fact, the serial dictatorship is Pareto optimal. And so that is the sort of the intuition for the proof here. And so the claim is that this mechanism is guaranteed to satisfy this property of Pareto optimality. Whereas random assignment, we know, does not satisfy that. We can definitely come up with examples where people would prefer to switch books. And so this is a particular dimension where the serial dictatorship is better than random allocation is Pareto optimal. Okay, good. So next we'll talk about another notion of goodness. So I'll pause for a moment. Are there any questions on Pareto optimality? Somehow there we go. Okay. My slides froze for a moment. Okay, so no questions, great. So, all right, so you learned about some mechanisms, you learned about one notion of goodness, Pareto optimality. Here's the next notion of goodness, strategy proof. So a mechanism is strategy proof if honesty is the best policy. This is sort of an informal definition. We'll say it again. A mechanism is strategy proof if lying about your preferences can't make you better off, right? So you can't do better off by misstating what you want. If that is the case, it's strategy proof, right? So there's no value in strategizing. So it's strategy proof in that way, right? Bulletproof means bullets can't penetrate. Strategy proof means strategies are not, it doesn't help you to strategize. You might as well just report things truthfully. Okay, so that's the notion of strategy proof. Does that make sense? So I think it's pretty straightforward definition. Good, people are saying yes. So now the question, we could ask the same question, right? Are these mechanisms that we looked at, are they strategy proof? And specifically, we'll think about the serial dictatorship mechanism. So this mechanism that we have been going over, is this strategy proof? So what do you think? You don't have to put the full argument. If you have any rationale, feel free to put it in the chat. But also you could just put your intuition. Do you think it's strategy proof? And if you have ideas for why, feel free to say why. So we have, all right, good. We've got some differences in opinion. So we have at least one no, we have some yeses. We have an explanation for why no. All right. Anyone else want to put their position down? All right, so we have a mix. We have a mix of yeses and nos. All right, so let's go through it. So I'll tell you up front. Well, should I tell you up front? Let's just walk through. Let's walk through the reasoning. Okay. So we still have yeses and nos coming in. All right. So first of all, so I'm just going to go through some different logical steps here, and hopefully I can convince you of each of these steps one by one. Okay. So first of all, your reported preferences don't affect your order. Okay, so we'll go back to momentarily to the mechanism. So just look in the lower left corner, the serial dictatorship mechanism real quick, right? We're randomly ordering people, and then we're matching each person with their most preferred book that is still available. Okay, so whatever you report, it's not affecting your order. We're just randomly ordering people, okay? So that's step one. Whatever you report is not affecting whether you get to choose first or get to choose last. Excuse me. Okay, so that's step one. That doesn't prove anything, but I think hopefully we all agree with that. Second, your reported preferences don't affect what anyone before you gets, right? No matter what you say, we don't even look at what your preferences are until it gets to your turn. So you don't get to, by reporting things differently, you don't get to choose who gets to go above you, you don't get to choose where you fall, and you don't get to choose what those other people books they end up getting, right? We're not even looking at your preferences until we get to your turn. Okay, so it can't affect, your preferences can't affect what anyone gets before you. So therefore, your reported preferences do not affect what books are available once we come to you, right? We get to you and there are some books available, and those are the books that are available regardless of what preferences you specified. On top of that, the serial dictatorship is going to give you the best available book on your turn according to the preferences that you have reported. So this is by the definition of the serial dictatorship. Once we get to your piece of paper with your listed preferences on it, we are going to go down and give you the book that you have stated that you most preferred, that amongst those books that are still available. Okay, so we'll give you the best available book according to what you have reported. So any misreporting that you do could only result in you getting a book that you like less, or the same, but you certainly aren't going to get a book that you like more. So in the best case, you lie and it doesn't actually affect anything. In the worst case, you lied and said, even though you don't like natural language processing, not to pick on that subfield, even if you said you didn't like it, you might end up getting that, or sorry, if you actually don't like it and say that you like it, all that might happen is that you actually get that book that you said you like when you actually don't. Okay, so this is the logic for why it is, yep, so good. So people are saying, yes, it is in fact strategy proof by this reasoning, right? So you can't get any better off by misreporting your preferences. So honesty is the best policy in this case. So it is in fact strategy proof, this mechanism, because you cannot benefit by strategizing. You might as well just truthfully report what your preferences are. That's as good as you can do. That make sense? All right. So we're going to introduce one more mechanism. So the mechanism here is called the abridged serial dictatorship. And what we are going to do is just like the serial dictatorship with one slight tweak. So step one, we're going to have each participant submit their preferences over their top K books. So even if there's 3 books, we'll say you're only going to submit your top 2, your favorite book and your second favorite book. Then we're going to randomly order the attendees. And in that order, we will give each attendee their favorite book amongst those that are remaining, according to what the reported preferences are. But if all this person's favorite books are gone, then we will give them nothing. So why would we do this? Well, the reasoning is I mean, maybe for 3 books, it's a little bit silly, but if I, had 100 books, maybe it's just painful for you to write down all 100 books. And so we're kind of looking for a shortcut, and we're saying, all right, well, I won't make you write your 100 favorite books. Just give me your top 10 books. And amongst those, when it comes to you, I'll pull this list out. And if any of those top 10 books are still available, starting with your most preferred, I'll give you that book. If it's not available, well, sorry, I can't help you. We'll just move on to the next person. Okay, so is it clear what this mechanism is doing? So we're having people report the key changes are in bold here. So people are reporting their top K books instead of their full list of preferences. And if all the books are gone, we're giving them nothing. So you can see the figure down below. In the Serial Dictatorship, people were submitting their full preference list over books. In this Abridged Serial Dictatorship, people are giving a truncated list. And by the way, Abridged Serial Dictatorship is not a commonly used term in the mechanism design literature. I'm just calling it this. Serial Dictatorship is a common term. Typically, I think this is called Serial Dictatorship with truncated lists. So maybe I should just call it that more directly from now on. But for this talk, we'll call it Abridged Serial Dictatorship. Okay, good. So someone mentioned speed. I think what they're alluding to is like this is faster in the sense that it's faster for the participant to write down their preferences. They don't have to write down a list of 100 items. They just have to write down a list of 10 or whatever K is. Okay, so it sounds like this is making sense to people. So the question then is the Abridged Serial Dictatorship strategy proof? And what do you think? We've got some no's. We've got some yeses. All right, good. It's always interesting when there are both yeses and nos, because then we have something to talk about. It's boring when everyone says the same answer. All right, so we're actually going to, rather than reason through whether this is strategy proof, we're going to do it by example. And this is where we get to the part where you join this group. If you would like to be considered, I'm going to choose some people randomly from this group to participate in this little game that we're about to play. And on top of that, I didn't mention this before because I had never done it before, but we're going to do a mix of randomization, and I'm going to choose one person who I feel has been participating a lot and giving some thoughtful comments in the chat. And there are many of you who have been doing this, but I'm going to choose someone that I think is one of the multiple people who have been doing a great job of giving thoughtful answers here. So I'm going to write down this person's name right now. All right, so Genevieve, and just to be clear, many of you have been giving a lot of very thoughtful answers in the chat, so I really appreciate that. But just calling out Genevieve because I think she's one of the multiple people who's been giving some good answers here. Okay, so Genevieve, the thing that I'm going to ask you to do is change your chat so that you are sending to me instead of sending to everybody. Because I'm going to ask you to submit your preference list to me, and we need to, it needs to be privately submitted to me. Okay, so if for everyone else, I'm going to randomly pick some people from the Facebook group. So let me pull that up. All right, so we got a lot of member requests. All right, so let's see, how should we do this? We're going to do a combination of first come, first serve. So here's the first person, and then the next one I'll do randomly. So okay, so I just typed in the name, Morija Oduwole. Sorry if I'm surely mispronouncing your name. But if you, so please reply in the chat, Morida. I'm just going to start typing people's names, and basically whoever responds first. So please respond so that I know that you're still here. So here's another person, but we need you to, so either Moridwa or Adronmu. Samuel, Emmanuel. Any of you guys here? There we go. Excellent. So we got Samuel here. All right. So we're going to play the first game with Samuel and Genevieve. So Samuel, if you could also change your messaging to just be to me. And so we're going to play this with 2 books. So there's 2 people, 2 books, and we're actually going to play with these 2 books here. So this is out of date. I don't have these books anymore. I gave them away last time we played. These are the 2 books that we're going to use this time. And these are also very good books. So book number 1 is called Atomic Habits. So this is a book about habit formation. I really love this book. It's a New York Times bestseller. It's called Atomic Habits. This is book number 1. It's about creating habits. Book number 2 is called The Craft of Research. It is basically about sort of principles for conducting research, writing research papers, going through research process. Both of these are very good books. You can't go wrong either way. And so what we'll have the 2 of you do is specify. So Genevieve, you're going to be person 1. You know what? Let me write these down so that I don't forget, so that I actually get you the book. So this is Genevieve. And then we have Samuel. Emmanuel. All right. And so we are choosing between these 2 books. Actually, do I have, yeah, too bad I don't have the right pictures, but let me just put them here. So this is Atomic Habits. And this one down here, this is The Craft of Research. Okay, so what we're going to do is, Genevieve and Samuel, you're going to submit your preference lists. So tell me, just like I have here, say, submit to me in a private message. Either 1 is greater than 2 or 2 is greater than 1. Okay, so I need both of you to submit. Oh, yeah, so book number 1 is Atomic Habits. Book number 2 is The Craft of Research. Does this make sense? And sorry, to be clear, this is the Serial Dictatorship the full serial dictatorship, right? There are no truncated lists here because there are 2 books and Genevieve and Samuel are going to specify their full preference list. And what I need to do is randomly choose between Genevieve and Samuel to see which is going to be chosen first. So let me do that. So we've got Genevieve's sticky note. We've got one for Samuel. Okay, Samuel, you just gave me a single item. So can you tell me the first and then the second most preferred as well? I mean, I think I can infer it, but I just want to, yes, perfect. Okay, so let me randomly shuffle these up. All right, so person number 1 in the serial dictatorship is Samuel. Okay, so Samuel is person A, and person 2 is Genevieve. So let me just put this down. So this Samuel was person A, meaning they chose first. Genevieve was person B. All right, and so they both submitted their preference list. So let me put them in here. So Samuel said he preferred book 2 over book 1. Genevieve said she preferred book 1 over book 2. Okay, so to go through the serial dictatorship, so we've randomly chosen Samuel. So we got to Samuel, we looked at his preference list. He said he prefers book 2 over book 1. And of all the books available, well, they're both available. Book 2 was The Craft of Research. So we are allocating that to Samuel. Congratulations, Samuel. Now we get to the next person on the list, Genevieve. Genevieve, there's 1 book remaining. So we look at Genevieve's preference list. It just so happens that her most preferred book is the one that is still remaining. So Genevieve is getting her most preferred book. So just so happens, it wouldn't always be the case, but they're both getting their preferred book here. So congratulations, guys. Let's see, send me also, Genevieve and Samuel, in a private message, your email address so that I can contact you about how to send this to you. Okay, so we'll do this one more time. Let me write down. Okay, I guess I can go back and get these messages after the fact, or else I might send you a message in the Facebook group if I lose your email in this thread. Okay, so let's go to the next one. This time we're going to do the abridged serial dictatorship. Okay. So there's only 2 items. So what does abridged mean here? Well, you're only going to specify 1 item, okay? And unlike this last time where different people were, it just so happened that Genevieve and Samuel had different preferences, right? Each of them preferred a different book most. So to make it interesting, we're not going to use books this time. We're going to use money. So what we're going to do, well, specifically, we're going to give you data. So we'll use, so you'll give me a phone number, a prepaid phone, and we'll add some data top up to your phone. So you can hopefully watch, YouTube video, Tim Roughgarden's YouTube videos if you want, but really you can use it for nothing or for whatever you want. You're not bound to use it for anything in particular. Okay, so there are 2 options here, right? Option 1 is $10 USD in data. Option 2 is $9 USD in data, okay? And you're going to specify, whoever is chosen here, which of these you prefer, right? You're going to say which of these you prefer over the other one. And remember the rules. We're going to shuffle between the 2. Whoever gets is chosen first gets their top choice if it's available. And of course it will be if you get to choose first. Whoever goes second gets, if their top choice is available, they get that. If not, then they get nothing, okay? So there's a chance that you get $10, there's a chance you get $9, and there's a chance you get nothing. In which case, I'm sorry for getting your hopes up. But in the spirit of, the actual, we'll go with the actual mechanism as it is. So now we need to choose some people, right? And think to yourself, by the way, what you would do, and is this strategy proof, this mechanism? So let's choose some people here. Oh, by the way, so I already chose some people. Did they comment? If I already chose you, let me see. Oop. Sorry, guys. All right, let me minimize this for a moment so that I can actually see the where'd the comments go. All right, here's what we're going to do. First of all, if I already mentioned, there were two people that I listed. But I've lost them in the chat thread. So if I listed you already, please type in all caps that I said your name. Oh, thank you. Oh, wonderful. Thank you so much. Okay, so are those two here? So Anyeka just gave the names. So I want to send to everybody. Where's everyone? There we go. All right, so are either of these two here? And if not, we're going to take a different approach here. I am a different approach. You are a different approach. Okay, we're taking a different approach because we haven't heard from either one of those guys. So what we're going to do is, if you joined the Facebook group, type in the chat, I joined the Facebook group. I'm going to confirm this after the fact. So if you did not join, we will, yes, okay. So we have a bunch of people who joined. All right, so now I'm just going to randomly pick some. I'm not looking at the screen. Let's see where I land. All right, here's one. Maybe you guys can see that, but I'll type it in. All right, and so you are person A. Make that a little bigger. All right, and person B. So closing my eyes. Let's see who we pick next. Paul. All right, good. So we have our participants. So Paul and Ola Milekan. Sorry if I'm mispronouncing your names. So step one is so I'm going to go back to full screen mode now. But step one will be Paul and Olamilekan, change your messaging just to be sending a direct message to me rather than everybody. Okay, and just send me one right now to test it out. Good, we got one. Yeah, one male and one female would have been nice. If I had a better way to randomize that way, that would have been nice. So, okay, so hopefully we've got, okay, good. Both of you. Great, okay, so you both sent messages. So what we're going to do now is, so this is the abridged serial dictatorship, right? So you are only saying the one item that you prefer more. So do you prefer option one or do you prefer option two? You don't get to say, unlike before, people would say that they preferred one greater than two or two greater than one. Here you're only giving me a single number. Okay, so you're telling me you like option one or you're telling me you like option two. So, okay, so we have one of our answers and we have our other answer. All right, so now let me do the ordering. All right, so first we randomly shuffle these up. And here we go. So person number one is Paul. Okay, so Paul chooses first. So let me go back to this. Paul chooses first. And Olamilekan chooses second. So now let's look at their preference lists. So Paul's preference was, whoops, exactly what I was, that makes it interesting. So Paul preferred two. Okay, so how does there's the preferences. So how does the abridged serial dictatorship work? So we randomly assign, or right, so we already randomly chose Paul as the, oops, sorry. Paul is the first person. We go through his preference list. He chose two. So we're going to give him a data plan of 9. So note that what Paul, if I took at face value what Paul is saying, he's basically saying he prefers $9 to $10. Nevertheless, we're allocating the $9 to Paul. Then person B, Olamilekan, comes in, says they prefer 1, and we give them their favorite amongst all those that are available still, and $10 is still available. So Paul chose first and got 9. Olamilekan chose second and got 1. So what do you guys think of this? Is this abridged serial dictatorship strategy proof? Why do you think Paul, right? Paul got to go first, right? Paul, you got to go first, it turned out. And you said that you liked $9 more than 10. So edit says it is strategy proof. It is not strategy proof. It's definitely not strategy proof, right? And Paul is the perfect example of this, right? He very reasonably chose something that, like, I think we can assume that Paul actually prefers $10 to $9. So why did he choose $9 instead of 10? Because he was concerned that it could be the case that he chooses second, and he's Paul, I'm guessing what your reasoning is, even though you say, Paul says that he was being honest, but I don't believe you, Paul. I think that Paul was thinking that Ola Mileken was probably going to choose 10 and was being defensive, as someone said, and thinking, well, if he's definitely choosing 10, I would rather guarantee that I get 9 than have a 50-50 chance of either getting 10 or else getting nothing. What really would have been too bad is if both of them were reasoning in that same way, right? But this sort of shows that this is definitely not strategy proof, this abridged serial dictatorship, because there's reason to strategize. If both of them would have reported truthfully, said $10, one of them would have gotten nothing, right? So this is an example to show that the abridged serial dictatorship is not strategy proof. But remember, the serial dictatorship was strategy proof. So that's just a very small change, really changed the properties of this mechanism. Okay, so what are the things to remember here? The key takeaways, I think. One is the rules of the game matter. 2, small changes to the rules can make a very big difference. So, okay, in what's remaining, I'm going to breeze through a few different things that I think are kind of interesting. So here's a discussion that I think we'll have to take. This is for you to think about afterwards. And this is going to be important, and we'll actually have a contest on this, a mini contest. So the question is, can you think of other systems you regularly participate in that are clearly not strategy proof or do not produce Pareto optimal outcomes? And what are some similar problems, real world problems that feel similar to these book giving problems? And what's the general version of this problem? So we would discuss if we had more time, but I leave you to think about this. And here's one example, right? So National Youth Service Corps, many of you maybe have already participated in this, if not will soon, right? So what goes on with the NYSC? So we have these different regions in Nigeria, right? So we can break the country down into different regions, different geopolitical zones, break that further down into different states. And if you've gone through the NYSC process, you know that you submit some form of preferences. You say what states you would like to be deployed to. And there's some constraints. You have to choose different, states from different geopolitical zones, 2 from the north, 2 from the south. But essentially you're expressing your preferences. You're not giving your full list of preferences, right? But it is some truncated and constrained list of preferences. And so we could think of the NYSC matching problem. Instead of matching books to people, participants, we're matching students and states. So we're giving people their PPA, their assignment is basically a matching problem. I see another number of interesting examples given in the chat. University admission, this is another good one. So here's the contest for you. We're calling it local challenges in mechanism design. Okay, so here's the goal. So identify a real world problem in your region that could benefit from the tools of mechanism design. So the prize here is going to be a mechanism design book or course of your choice. So I've got, if you want, you can have a book right off my shelf. I've got a bunch of them. Or if you want a course, there's a lot of good online courses as well. Actually, one of them by Kevin Leighton Brown, who is either giving a talk already or is giving one soon at DSN. He also works in this field. And so if he hasn't had his talk already, I encourage you to go to it. Okay, so this is the question. The submission deadline is just over a week from now. Okay, so Monday, November 23rd, 2020 at 11:59 p.m. Nigeria time. You can submit early if you would like, and I will probably have one round of quick feedback. There's no promises to this. It will kind of be first come, first serve. And it's also, depends how much time I actually have to give feedback. but I'll try to give feedback if people submit early. And we'll announce the winner in the group, the Facebook group, on Monday, November 30th, 2020. And so the winner can get a book, as I said, or a course of their choice. Okay, so what do you do here? The first form is just a brainstorming form. This is what you can use to just get some ideas. Okay, so those with no Facebook accounts, I will connect with the DSN folks as well, and have them pass that information along to, yeah, maybe we'll do that. We'll have them pass the information along to those that attended this course. Hopefully the DSN folks are able to do that. Okay, so the first of these forms is a brainstorming form. This is not the contest form, but this is what you can use to get some ideas. I've sort of laid out a number of questions that I think are touching different areas that can give you some indication of what could be relevant areas. And by the way, there's more than just these, right? I've given this tutorial has been about a subset of mechanism design problems. It's about, you know, some of these matching problems, but there's much more than that that mechanism design covers. So I encourage you to go through that brainstorming form. And then once you're done, just go through the submission form. Just submits, answering a few questions, posing, giving a description of the problem. And if you want, you can use that Facebook group for asking questions and things like that. Okay, so these are the links. Let's I'll add the links right now. All right, yes, resources to learning mechanism design, go to the Facebook group, and there is a post there that has a bunch of links. I'll sticky it if it's not stickied already, and I'll add, as soon as this ends, I'll add all of you, I'll accept you all to the group who requested to join. Okay, so these are the groups to enter into this competition, this like mini contest. And note that this is related to some a much bigger contest, global challenges in economics and computation. So we just had, so last year I ran this same sort of thing. We had a lot of people submit from Data Science Nigeria. So this was sort of $150,000 in research grants. So we had a whole committee here and a workshop as well. And Bayo, actually, the head of Data Science Nigeria, was one of the workshop organizers, and has done fantastic work in sort of getting people from DSN to attend various conferences related to mechanism design, and really helps a lot in organizing this workshop. So we had a lot of submissions from all over the world, and basically, so I'm not really describing what exactly we were asking for, but it's very similar to this contest this small contest that we're giving right now. The hope is that promising contest entries for this mini contest can eventually be used for this bigger research grant proposals for those of you that are interested. I'm guessing we're going to have it very soon again, probably next year, but there's no guarantees that we'll be doing this again. So just to answer a quick question, well, let me go through the rest of this first before I answer questions. So yeah, so last year for this global challenges in economics and computation, we had 58 submissions. Over 20% of those were from Nigeria, and we had multiple finalists from Data Science Nigeria put forward some really cool entries. If you were one of those people and you happen to be here, feel free to mention it in the chat. And if we had more time, I would go through these details. I've just listed one of them here. The second one here has to do with Nigeria using security games. We haven't talked about security games, but this is a different concept in game theory related to mechanism design for curbing insurgency in Nigeria. But if you go to this gcec.org/winners, you can see a list of many different entries, many of them which were from previous attendees from Nigeria, and specifically in data science Nigeria. So we've had an awesome showing in the past, and I expect that you guys are now going to be carrying the torch. And I really hope that you become some future experts in this field if you love it as much as I do. It really is a fascinating field. It's about understanding how to design the rules of systems given the incentives and potential strategizing of participants in that system. So this is really, a tool that can be used for designing systems in the real world. And I hope that you utilize this to lead to some positive change in Nigeria in some area that you care about, whatever that may be. That would make me very happy, and I would love to hear from you if you do something like that. I would go through these winners, but they're listed on the website. We're about to end in 2 minutes. So here are some different topics that you learned. The slides are shared with you. Here are some books. The Nobel Prize winner in economics this year was in auction theory, which is a subfield of mechanism design. So you can look into that if you want. But yeah, so the next step, join the Facebook group. You can see all sorts of links to learn more about mechanism design there, and joining the mechanism design community. And again, these are the forms if you want to participate in the contest. If you want a job referral for Facebook. I'm also happy to meet with any of you that are interested. I guess the way to do that, I'll see if the Data Science Nigeria folks can send a link to schedule meetings with me if you're interested, just a short, 15-minute maybe. If you're interested in any of this, would like to learn more, I'm happy to talk with you, see what I can do to help you succeed here. Yeah, so I guess that's it. Kudos to you guys for sticking with this, for even getting to DSN to begin with. I'm really excited to have taught you this, and I'm looking forward to seeing what ideas that you have for using mechanism design in the real world. Happy to take any questions, but probably we're about to get kicked out and the meeting ends. I'm actually not sure what will happen here. My Twitter handle, I'm not a very active Twitter user. I think it's Sodomka, perhaps. I don't even know. Just look me up. Eric Sodomka is my name. How about the grand? Paul is asking, what does the grand mean?
Hello, Rising.
Sorry.
Fine. Good afternoon. I'm gonna say your profile picture, you're soft like mad. You're soft like bread.
I'm sorry. Sorry, I didn't hear you.
From someone. Sorry, I guess that was a mistake from someone. All right, this is Voice of Lakon. Thank you very much, Dr. Eric. It's been a wonderful session. I think all questions are answered. I'm very sure all doubts about mechanism design have been addressed. I mean, just checking the chat room, and we have over 500 messages. I mean, I'm like, wow, this is awesome.
Yeah. Thank you guys. Kudos to you guys for actively participating. Oh yeah, one last thing for those that got the 4 people that participated, please send me your email again so that I don't have to go through all these chat messages to find it. So that I make sure that you get the things that you won. So that would be Paul. Okay, great. Thank you, Paul. And if I don't get them here, I think hopefully I can get them the emails from the DSN folks. So thank you so much. And yeah, I'm guessing you probably have I don't know if you have another session to go to right now, but feel free to join that if you do. I'm happy to stick around and answer questions. But if there's another talk, you should probably go to that. And I think there probably is, correct? Is one of the DS organizers here?
Yes. So
Yes.
next session starts by 6 p.m. That's in 1 hour time. But then, I mean, if conversations still have to go on here, why not? Please, we still have like 10 minutes of conversation here. So
Excellent.
Still
Great. Okay, so feel free to put questions in. In the meantime, I'm going to make sure that I get the email addresses of everyone. So feel free to type your questions. Right now, I'm just making sure I have everyone's email addresses to contact them. Samuel, did you send your email address? All right, Samuel, if you send me your email address, feel free to, or if you could, please resend me your email address. Otherwise, I'll find some other way to get it. And let me also say, if you want to contact me, you're welcome to do so. Here's my email address. Okay, so now let me go through some questions. Okay, so let's see. So can mechanism design be used in all fields? Jeremiah asks. So I guess mechanism design is, yeah. So what this question is similar to is like, can algorithm design be used in all fields? So in that sense, designing algorithms is sort of pretty general. Like anytime you need to design a procedure for something and the efficiency of that algorithm is useful, then algorithm design is important. So mechanism design, I guess, where it is useful is when there is some, the participants, you're building a system for some self-interested participants, or there's some incentives that these participants have, right? If the participants will just do whatever you want them to, then you're sort of just designing an algorithm. So what really distinguishes mechanism design from just designing an algorithm is that there's some notion of strategic agents, some strategic participants. So anywhere where there's some self-interested behavior, strategic participants, I think mechanism design is useful. So, a lot of real-world problems that are dealing with humans, mechanism design often does come into play. How can we use this in data science? Well, I can point you to, there's a workshop, I think called, is it Incentives in Data Science? that could give you some idea. And you know, I guess it depends. Are you thinking, you know, so well, okay, so I guess the team that I am on is called at Facebook is called Core Data Science, and I work in mechanism design. So I guess there's some, you know, superficially anyway, there's some intersection there. So I guess, you know, these are two different tools, you know, where, you know, data science is a field of dealing with data, mechanism design is a field of designing rules of systems. So you could, you know, imagine, you know, if you have data on participants using some existing system, for example, you could use that to perhaps try to understand the preferences of those participants, or you know, what is motivating those participants, and then use that to then consider alternative designs and what might happen in those. So that's just one idea. It's not the definitive answer, but they're definitely connected. Okay, Genevieve says, does it mean if our mechanism design does not meet the notion of goodness, the ones that I specified, Pareto Optimal and strategy proof, we should change the design? No, that's not necessarily the case. Good question. So I covered two particular notions of goodness, but there are many notions of goodness. You know, maybe you don't care if agents strategize or not. Maybe what you actually care about is, you know, we also mentioned like the speed of the computation, how complex is it for the participants to express their preferences? You know, some notion of efficiency. Are we actually achieving outcomes that are maximizing the welfare of participants? We might care about some notion of fairness. So there are many different desiderata, they're called, or sort of criteria that you might care about. And Pareto optimality and strategy proofness are just two of those that you might consider. More questions. Thanks for all the positive comments, guys. It really makes me feel good. All right, so all right, I'm gonna start. Oh, here we go. Got a couple more. Oh, I think I answered that. Mechanism design fused with data science. Those are definitely, you know, an intersection I'm interested in. Resources to learn more about mechanism design. So in that Facebook group, which I will add you, I will accept all those all those requests to join momentarily. I will also make sure that I will bump the post that gives a bunch of useful resources right after this meeting. Recommended books on mechanism design. Oh yeah, this is a good point. So the Data Science Nigeria library has already a bunch of books on mechanism design and game theory. And I think they have some that are my favorites. I think I mailed some of them were mine, in fact, previously. Let's see. So actually my favorite book, okay, so let me just say a couple, and you can consult the Facebook group for more links. So, okay, so here's one, Computational Social Choice. This is by Vince Konitzer and Ariel Perkasha. This is actually available for free online. And I believe there's a link to it in the Facebook group. But this is a good one, a relatively recent book on a subfield called computational social choice. So like, for instance, voting, how do you design rules for voting, aggregating people's preferences? That falls into this area. Another book that I really like, well, so one that I have here, it's a good one, is just called Game Theory, plain and simple. So game theory is about basically, you know, there's some system in place and you're reasoning about how participants will proceed. mechanism design is sort of like an inversion of that, where the system isn't in place, you are designing the system. And then once you have that system, then participants are going to behave strategically. Another book I really like, what is it called? Multi-agent systems, maybe? It's actually by Kevin Leighton Brown, who's giving a talk at Data Science Nigeria. It's actually one of my favorite books when I was in school. Let's see how much time we have. Just look for Kevin Leighton Brown's books, and it's something like multi-agent systems. Does mechanism design require machine learning knowledge or mathematics? It is, okay, that's an interesting question. I would say there are different sort of areas of mechanism design which are using, there's some, these are sort of, I don't know, there's a Venn diagram here where there's sort of theoretical work in mechanism design where definitely mathematics is like a critical piece. This is proving theorems, things like that. And then there's a machine learning side, which is, well, there's different flavors of it, but one is around automated mechanism design. So could we use sort of a machine learning approach to output a mechanism? And there's some cool work there by a number of folks at Carnegie Mellon, Duke, and Harvard, amongst other places. But I guess, automated mechanism design would be, or computational mechanism design, those would be good keywords to search for if you're interested in the intersection of mechanism design and machine learning. All right, I think that's probably, unless there's any other pressing questions, I think have gone over the 10 minutes. I think I've answered everything, I hope. Cool, I hear some ideas people have related to route optimization. Yeah, like network routing, this is definitely relevant. All right, so we'll end it there. Again, these are the links. Again, I'll post more stuff in the Facebook group. If you're interested in Facebook jobs, feel free to fill out that referral form. And if you're interested in just meeting with me, if it's okay with the Data Science Nigeria, Eric for president, we've gone through. Don't get me started on that. We're still figuring out the U.S. president, or I guess we figured it out now. Yeah, if you want to meet with me, I'll send something to the DSN folks, and hopefully we can make that happen. Because if you're interested in this area and would like to learn more, if you're interested in PhD programs or jobs, and especially if you want to use this to make Nigeria better in some way, I want to help you do that. And that would really inspire me to hear someone going out and doing something like that. So would love to help you succeed in that way. So, all right, so thank you guys very much. Really enjoyed it. You did an awesome job. Tons of engagement that really was satisfying. So I hope you guys learned something, and I hope we can continue in the group. And looking forward to reading some of your proposals in the submission form. All right, have a good one.